And now let's move forward to the last part of this session, which is Speedy, the new protocol from Google. And it's actually the missing bit in the TCP stack. So it's sort of, not completely, sort of a session layer. Well, actually, it's a framing layer that implements parallel streams above a single TCP or TLS session. And you could use Speedy for anything. So anytime you have to deliver parallel streams over a single TCP session, whatever your application may be, you could use Speedy, but it is optimized for HTTP. And the idea is that regardless of what you're doing, you use a single client-server TCP connection, and that's based on IP addresses, not host names. So the tricks where you would use 10 different host names to open multiple TCP sessions to the same host don't work with Speedy. Speedy sessions are based on IP addresses. However, to fix numerous problems we discussed in the last half an hour, the HTTP requests and responses are streamed in parallel over that TCP session, and you will see how that works. And this is really important from the client side, well, in both directions, HTTP headers are compressed by definition. And the dictionary they use for compression is such that you get the maximum possible compression on HTTP headers. And stream data is flowing over this session in parallel, so you could have mixed packets from different streams mixed in time, and all the responses are sliced in smaller chunks so that we don't have head-of-line blocking. So, the question that I will answer immediately, is Speedy a session layer protocol? I would say no. It implements some of the functionality I would expect from a session layer protocol, but it's just the framing layer. It does not include, for example, a mechanism to re-establish TCP session if it breaks. It doesn't include the mechanism to open parallel TCP sessions if needed to improve performance, like multipath TCP does. It cannot open TCP sessions to multiple IP addresses belonging to the same host to solve multi-homing, etc., etc. So it is a framing layer and nothing else. So no, I would not call it a session layer. Next question. I imagine it's not prohibited to use parallel TCP/Speedy connections. It's not prohibited, no, but the standard and the current implementations use the idea of having a single TCP connection. So you see, you have to figure out what you want to optimize. If you open new TCP connections, then you have to you spend one round trip time just establishing the session, and then you have the initial problems with congestion window. And if you already have a TCP session and it's fully utilized because of big window sizes on both ends, for example, then it's hard to push more data through parallel TCP sessions. Because remember, here I can send all the requests at once and the response are coming back in parallel. Next one. How will Speedy break stateful inspection and passive inspection like Wireshark? If you're talking about layer 4 stateful inspection, Speedy doesn't change anything. It runs over TLS usually anyway. So it actually doesn't change any inspection because you couldn't inspect TLS data in regular HTTPS sessions anyway. And Wireshark will simply have to have another load-in module, and I'm positive they already support Speedy in the latest releases. So I don't see much change in the inspection gear once Speedy is deployed. Next one, can I use Speedy without TLS, so on HTTP and not on HTTPS? In theory, yes. In practice, no one is doing it. So everyone is combining Speedy with TLS. Speedy and header compression, it will be fun to deal with header manipulation techniques in load balancers. Well, it depends on how the load balancer is implemented. So if you're using dedicated ASICs to do the load balancing, and if those ASICs are able to, for example, insert fixed length X-forwarded for header in the TCP session, yes, those vendors will definitely have a serious problem with Speedy. On the other hand, if you do everything in software like F5 does, then this is just another software operation to add. And by the way, F5 already supports load balancing with Speedy. So you could just configure Speedy on F5's load balancer and have Speedy toward the clients and regular HTTP sessions toward the inside servers. So the previous question was about level 7 inspection that can be inspected with server certificates provided. Oh, that will be an interesting problem. And yes, you will have to upgrade the existing tools. So if you're talking about layer 7 inspection, first you have to decrypt the session. So you would need SSL termination and then inspection and then maybe re-encryption. In that case, it would be better if you terminate Speedy on a load balancer and then do inspection after the load balancer and use HTTP, regular HTTP between load balancer and the inside servers. Okay, and now let's go into some of the details of Speedy. And there are not many details, by the way. Go and read the draft. It's really well written and well explains what it's doing. So this is how you create a new stream. And you could have as many streams as you wish on a single TCP session. Streams can be bidirectional, so regular HTTP requests, or unidirectional, for example, server push. And streams can be opened by clients or by server. And with the client opened streams, this would be regular HTTP requests. But what the server can do is it could figure out that the client would need some data anyway. So the client requests a web page and server says, okay, with this web page, you will need this style sheet and you will need this JavaScript and you will need this and that, and starts pushing those resources to the client before the client has even asked for them. So it's an option. I don't think any web server has implemented that, but it's definitely an option. And then you can specify the priority. So you could say style sheets are more important than images. And then as the data is packed into the TCP session, actually the sender uses priority queuing within the TCP session, which obviously is not something extremely reliable because there's still the TCP buffering after that, but at least we can try to put high priority data in front of low priority data. And HTTP headers are transported within the scene stream request, and as I said, they are compressed. And the other side replies with scene reply, and the reply already includes the HTTP headers, and then the response comes back in data frames. So you see, we have already removed one round trip time. SYN packets in Speedy, because it is on top of TCP, already carry the request and response headers. So, for example, this is how a Speedy session would be set up. First, you would have to send the regular TCP SYN packets and ACK, and this would cost you first round trip time. And then TLS would have to be established. This would cost you the second round trip time. But after this is done, you have a working Speedy session, and you could use it for however long the server is willing to keep the Speedy session operational. And the idea is that Speedy sessions would be operational for a very long time. They are talking about minutes or even hours. And then optionally, you would set the parameters of the Speedy session and send the HTTP requests, the replies coming back in third round trip time. So you need 3 round trip times after you decide to go to a new web page. And after that, Speedy session is established, so this no longer applies. You get subsequent data in 1 round trip time. And now for sample transactions, GET is very simple. So you send the SYN stream packet with a fin flag saying this is the last packet in this stream. I have no more to tell you, and the headers are included in the SYN packet. And then you get the SYN reply with the response headers and data, and the last data packet would have the fin flag set. So we are done. Post SYN stream with the headers, and then post data in subsequent data packet, which can obviously be sent immediately after the SYN stream packet was sent, so there is no need to wait for the reply, and then the reply coming back with SYN reply. And if the reply if the reply is redirected to another web page, then it would have the fin packet. If the reply has data, then you would have the optional data packets. And here's an example of how the streamlined Speedy would work. So you first request the HTML page, you get the reply with the data, you parse the data, and then you ask for all the resources in parallel. Everything you need on that web page, you ask in parallel. And with the priority, you ensure that first you get CSS, and then you get JavaScript, and then so these are the replies, and then you get CSS data first, and then you get JavaScript data, and after all that is transmitted, you start getting the image data. So this works really well when the transfer time is smaller than the round trip time, because you get all the data you need for a web page in 2 round trip times. And now, after all these goodies, some harsh reality. Is Speedy faster than HTTP? Of course, Google is saying, yes, of course it is. Sites load twice as fast. And if you read blog posts from Speedy developers, they tell you how they added Speedy support to Apache server. Yes, you can use it, and web is twice as fast, yabba dabba do. And it turns out that they're using fine-tuned examples where you have lots and lots and lots of images on the same web page. So, of course, they're using examples that are fine-tuned to Speedy's advantages. And then Microsoft did some tests, and as expected, they figured out that Speedy is slower than HTTP. And that was not a fair comparison, because they were testing Speedy with TLS. And of course, it's slower than HTTP because you have that extra round trip time. a more realistic assessment is in this blog post. And what this guy is saying is he was doing loads of tests with Speedy. And the way he was doing tests was he actually implemented Speedy proxy in his testbed, added delay after the proxy between the client and the Speedy proxy. And then he went to, I don't know how many, let's say 100 different websites and measured whether they work faster or slower. And he said, well, Speedy is in principle a bit faster, but in reality, the web pages, because of all the performance hacks we're using, are coded in a way that doesn't make Speedy any faster than HTTPS. So yes, in principle, Speedy is a bit faster than HTTPS. On real life data, there is not much difference because real life websites use things that make Speedy nearly useless. And now for some real life experience. So for Speedy, you need a web server with TLS. I haven't seen Speedy used anywhere without TLS, even though it is an option. And then you need an extension for TLS that allows you to to negotiate the next protocol. So you need this extra bit of TLS that allows you to say, well, actually it will not be HTTP running on TLS, it will be Speedy running on TLS. And Speedy is now available in shipping Chrome and Firefox browsers. There is mod Speedy for Apache. You can download it from Google Code and install it in your Apache web server. There are patches for Nginx. There is some development code for HA proxies, so the high availability proxy for Linux. It's supported by F5 Web Accelerator, so F5 already has Speedy running. And it's used by some really large websites like Google, WordPress, and Cloudflare. And if you really want to know whether a certain website uses Speedy, go to speedycheck.org, enter the URL of the website, and this speedycheck.org goes through all the different tests, step by step by step by step, and tells you either this site is using Speedy, or this site could be using Speedy but it doesn't, or this site couldn't possibly use Speedy because, for example, it doesn't support next protocol negotiation with TLS. So go out there and play and see who is using Speedy and who's not. These are the three I found. And now I have 3-4 questions on Speedy. Will Speedy over TLS remove any performance gain over normal HTTP over TCP without Speedy? Let me try to understand the question. The only answer I can see to this question is what I already had on the previous slide. So Speedy is a bit faster than HTTPS. It might be, depending on the environment and your application, a bit slower than HTTP. But in reality, more and more web services run over HTTPS because of security reasons. So if we are assuming that our web service would run over HTTPS anyway, then yes, it makes sense to start considering Speedy. Is it a good idea to use Speedy with TCP fast open? Actually, you can't use it. You sort of may if you would start TLS negotiations with the TCP SIM packet, because first you need to negotiate TLS. But that would only save you one round trip time from the whole web page loading experience. So no, I don't think it's a good idea. Next one, how do you see Speedy being adopted in short term, 3 to 12 months and beyond? Well, as you can see, it's available in browsers that are shipping today. So obviously, 2 other major browsers are missing, but these 2 already have, I would say, well, depends on your environment and your user base. For me, Chrome and Firefox are probably 50% of my user base. It's available, it's already being used by large websites like Google, and it's available in F5 load balancer. So if anyone that has an F5 load balancer with latest software release, turning on Speedy is just a configuration exercise. So I don't know how many people will decide Speedy is a good idea, particularly in the enterprise world. I do know that the largest web farms already use it. Next one, do you expect the big C vendor to support Speedy and NPN in their *** product line? No comment. I don't even want to start speculating what will happen with that product line. So absolutely no comment there. To get more information about my webinars, to register for an online session, or buy a recording or the yearly subscription, please visit my website.